Okay, welcome to another live stream, kind of a little impromptu live stream, but what I wanted to do is get a little caught up on some of the homework that we're working on. So what we're going to cover today is working on the characteristics of polynomials, and if I have some time afterwards, what I'll do then is go ahead and answer any questions that you guys have. So if you do have any kind of questions, working on. I'm not sure why my marker thing is not working. I guess I probably should have checked that out ahead of time. Oh, I forgot to plug that in. So let's go ahead and get that set up. Not really good for when you start the live stream. You should probably check. And I was wondering, I was like, man, do I have everything? I got all this like crazy stuff going on here as far as like my work, and then nothing was really showing up. So let's kind of cover a couple things as this is booting up here. We're going to cover characteristics of functions, and then what I'll do is get into binomial expansion and as well as real zeros of functions. So I'm going to look into covering those in another live stream, looking forward to tomorrow. So if those are the things you guys are looking into, make sure to check back in tomorrow. I'll try to make sure they're scheduled, as today I just didn't really have time to get the scheduling worked out. But there we go. My marker is now working. So just to kind of recap as you guys are getting in, if you do have some questions that I can answer, I have about 30 minutes that I'm going to plan ahead. So I'm just going to kind of get through this first section of the homework. We're just going to kind of talk about zeros and multiplicity, go ahead and talk about M behavior as well as number of zeros and extrema. And then what I'll do is I'll take a break before we get into the multiple choice questions. So let's go ahead and get started. Hey, Amit. Hey, Husan. Hey, Leah. Well, hopefully you guys, glad to see you guys on. What is 10 plus 9? That is going to be 19. So let's go and get on to that. But if you have some more questions, then I'll be happy to answer them at the end. But for right now, I'm just going to kind of get started into the content, and then we'll take some breaks and we'll answer some more questions on after that. So, all right. The first one is talking about determining the Y and X intercepts, which are also we talked about as the zeros, the M behavior, as well as number of possible extrema for each function to sketch the graph. Okay, so we're also going to be sketching the graph. And a couple things that we worked on, we were talking about the X intercepts, which is the real zeros. So it's not just zeros, but it's going to be the real zeros of the polynomial. And basically what we found is when we have a polynomial that's in factored form, that means each and every polynomial here is going to be, let's use a different color. All right, I'll keep that open. You can see that each and every one of these is separated by multiplication. So if we're trying to find the zeros, remember the zeros is when a function is set equal to 0. And man, oh man, what the heck? This is like really bad. Okay, there we go. So a couple things that we looked at. The X intercepts is basically when y is equal to 0, which is really the definition of the zeros. Now, in this case, we're just going to be finding the real zeros. So we're going to replace y with 0, and we're going to have 1/2 times x times, I'll just write that as x minus 2 times x minus 4 squared. Okay. Now, when we're looking at this, as far as like identifying, the zeros, we can apply the zero product property. As long as we have a product equal to 0, we can set each and every product equal to 0. Now, we don't need to mess up with or mess around with setting 1/2 equal to 0, because 1/2 is not equal to 0. So I'm going to group the 1/2 with the x. And it doesn't really matter where you group the 1/2 with, because what you'll see is each and every time any kind of multiplier that you have is going to just going to divide out. So it's not going to impact the value of our zeros. That's a horrible parenthesis. Okay, so now that we have the zero product property, we set each one of equal to 0. Now we can just go ahead and solve by using our inverse operations. Here I can multiply by 2/1, but you don't really need to like show your work here. I'm just kind of showing it so you guys can see. You can see x is equal to 0. So it doesn't really matter if this number was -1/17. It was, pi. Whatever that factor is going to be is not going to be impacting the zeros. We will get to what that impact is going to be. You add 2 here on both sides, so we have x is equal to 2. And then here we're going to have to undo the squaring first. Before we add the 4, we're going to have to take the square root of both sides. And therefore we'll have x minus 4 is equal to 0, so x is equal to 4. Now, when we're talking about the x intercepts, you can leave them like this, or you can write them as coordinate point. A lot of times when we're talking about the real zeros, we'll talk about them using, writing them as a set notation. And once we start talking about more different types of zeros, you know, this set notation will become very, very helpful. But I'm just going to write them as zeros, 0, 2, and 4. And then you could also label them as your x-intercepts. Now, before I get to the next example, I did not leave myself enough room here because I do not need that much room down there. So, all right, let's go ahead and find the y-intercept. So the y-intercept is basically going to be when, oh, I should talk about this. Did I talk about multiplicity? I did not talk about multiplicity. I need to add that in there. The intercepts with multiplicity. Okay. So before I get ahead, sorry, I'm just kind of got a little frazzled with my thing. So I got to kind of slow down and get myself caught back up. A couple things that we talked about here when we were looking at this in class is we looked at the multiplicity and how that impacts the graph. So we looked at graphs similar to this. We looked at the graphs and, you know, how they kind of behaved based on these values as well as the powers that they were raised to. And what we noticed is each one of these linear factors can be raised to a power. And based on the value of that power, that tells you the repetition of that 0. And if the repetition is going to be even, then the graph is going to bounce. And if the repetition is odd, or what we call the multiplicity is odd, the graph is going to cross. So I'm just going to represent multiplicity as m. So I'll just say in this case, m is equal to 1. For x equals 2, the multiplicity was equal to 1. And at 4, you can see that there x equals 4 it's a double 0, right? Because x minus 4 squared is x minus 4 times x minus 4. So we can say here the multiplicity is going to be equal to 2. All right? And I'll show you how that's going to be helpful as far as impacting the graph here in just a second. All right, so now I got to that. Let's go ahead and finish the y-intercept. The y-intercept, guys, is basically when x is equal to 0. And what we notice here is when I replace 0 in for x, now you could probably stop after here because you notice that everything is going to be 0 when you're multiplying it by one value that's equal to 0. But I'll just plug everything in. But therefore, you can see the y-intercept is when y is going to be equal to 0. Okay? All right, so now let's go ahead and sketch this graph. So I'm going to do my best here to sketch it up here, and then we'll talk about the end behavior. Oh, we got to get to the end behavior. So let's get this information, though, first. So we have x-intercept at 0. We have a x-intercept at 2. And we have an x-intercept at 4. 1, 2, 3, 4. Okay. Now, the multiplicity, again, as I mentioned, changes, helps us with that. Since the multiplicity here is 2, that means the graph bounces. I don't know if it bounces up or if it bounces down, but I know that the graph is going to bounce. For these two odd multiplicity, I know the graph is going to cross. So I'm just going to draw a line there so I remember that I'm going to be crossing. Now, to sketch the graph, we need to identify the end behavior. All right, and to identify the end behavior, it's helpful to be able to know what the expansion would be of this graph. So I'm going to kind of do this up above here. If I was going to expand this binomial, I would have x times x minus 2. And if I was going to do x minus 4 squared, you know, even though I know that answer in my head, I'm not really concerned about that. I'm only concerned with the leading term here, which would be x squared. All right, because when we're trying to find the end behavior, we're using the leading coefficient test, which means we're going to be looking at that first term. And then if I was going to multiply all of this all over again, I'll just kind of do my work over here, I would have 1/2 times x. And then if I was going to multiply that times x minus 2, my leading term would be 1/2 x squared. And therefore, if I was going to multiply that by another x squared, my final leading term would be 1/2 x to the 4th, ... Okay, the dot, dot, dots got really, really close. But the main important thing is we're not trying to multiply every single term. You can do that, and that's perfectly fine. But if you just go ahead and multiply like one binomial times the other binomial, you're looking for the highest term that expansion would create and just taking away that. Because that's what we're looking for is this leading term. Everything else is going to have a lower power in the expansion. So what I notice here is since my leading term, my coefficient is positive, and my degree is going to be even, then my end behavior is going to be that of a quadratic. It's going to rise to the left and rise to the right. So I'm going to go ahead and draw that in as purple. So my graph is rises to the left and rises to the right. So now all I need to do is kind of connect my two end behaviors through my zero. So it needs to go through. Oops. Let's try that again. It needs to go through, go through, go through, and bounce. Okay, so you can see the graph is roughly going to resemble a shape of a graph that's like that. And that's all I'm really looking for. for my students is, can they understand the end behavior, as well as do they understand kind of the multiplicity and how the multiplicity impacts those x-intercepts. The other thing that we're looking for is the number of possible extrema for each function and number of possible extrema. So one thing that we talked about is the number of possible extrema, or also known as turning points, is always going to be 1 less than a degree. So since the degree is going to be 4, then the number possible, or the possible number, again, possible number of extrema is going to be the degree minus 1, or a lot of times referred to as n minus 1. So we can say, I'll just say max extrema is going to be 3. Okay, and sorry, I should have given myself more work. Everything's kind of scrunched together, so sorry about that. All right, the next one is y equals negative 2x minus 2 squared, 2x minus 1 times x plus 1. Okay, so again, same thing. I did a really 2, 3, 4. I picked like the exact same thing. So again, if we want to find the x-intercept, same exact thing. Let's set up the zero product property. So I'm going to set my y equal to 0, and then basically set everything equal to 0. 2x minus 2. Now this one, I'm going to kind of like skip this step and just immediately go into the zero product property. Again, this negative is just like the 1/2. It doesn't matter which one you attach it to. The first step you're going to do is get rid of that negative symbol with 0. So it's not going to impact the zeros at all. So therefore I can set 2x minus 1 equal to 0, and then x plus 1 equals 0. Jeez, I don't have any room. All right, so now I can basically solve each one of these. So again, as I mentioned, you can like divide this by -1 on both sides. And here, okay, so therefore you'd have 2x minus 2 squared equals 0. You need to get rid of the square root by squaring. You need to get rid of the squaring by taking the square root, and therefore you're left with 2x minus 2 equals 0. To save myself a little bit of time, you're going to want to add 1 and then divide by 2. So therefore x is going to equal 1. Here you can add 1 and then divide by 2, so x is going to equal 1/2. And here you would just subtract 1, so x is going to equal -1. -1. Okay. So those are my x-intercepts, and now let's go and talk about multiplicity. You can see that this is the only one that's raised to an even power, so I'm going to say my multiplicity is equal to 2. Here my multiplicity is equal to 1, and then this one has a multiplicity equal to 1. To find my y-intercept, I'm just going to put x equal to 0. Now this one doesn't have a term that is just 0, so therefore I'm going to need to plug 0 in for each one and actually evaluate this. So I'll have 2 times 0 minus 2 squared times 2 times 0 minus 1 times 0 plus 1. Okay, so 2 times 0 is 0, minus 2 is -2. -2 squared is going to be a positive 4. So we have a negative times 4. 2 times 0 is 0, so we have a -1, and then times 1. So let's see, that's going to be -4 times a -1. So my y-intercept is at y equals 4. Now that's going to be helpful for us when we're graphing this. So I'm going to try to, I don't have any room. So I'm going to put the graph right here. All right, and let's label our y-intercept. So our x-intercepts, I'm sorry. So we have an x-intercept at 1. We have an x-intercept at -1. And I have an x-intercept at 1/2. You know what, let's space that out a little bit. We have an x-intercept at 1, x-intercept at -1, and an x-intercept at 1/2. So that's 1, and that will be -1. Okay, now again, notice that the only multiplicity that's going to bounce here is going to be at 1. And again, that's because the linear factor is raised to an even power. So I'm going to bounce here. And again, I don't know the direction. And then for my ones that are crossing, I'm just going to do the lines. All right. Now let's go ahead and take a look at end behavior. If I was to expand this out, I would have a negative. This would be, let's see, 2x times 2x would be a 4x squared, ... times 2x, minus 1 times x plus 1. Well, let's multiply those out. If I was to multiply 2x minus 1 times x plus 1, my leading term would be a 2x squared dot, dot, dot. And again, we don't need to actually multiply these out. We just want to find the largest term, right? The leading term, the largest degree. Now, if I were to multiply these two out with that negative included, my final part would be y is equal to a negative. Let's see, multiplying these two together, you're going to get a 8x to the fourth. So very similar to my last example. The only difference here is now my leading coefficient is now negative, but this is still even. So rather than the graph going rising to the left and rising to the right, it's going to fall to the left and fall to the right. So now the graph goes down here and down here. So now I just need to, again, go through kind of fitting, going from one curve to the other. So I'm going to go to this 0, it bounces, and then it's going to come up and come through that 0. And there you go. Again, the max number of zeros is always going to be, or max number extrema is always going to be one less. So the max extrema is going to be 4 minus 1, which would be 3. And again, that's the maximum number of turning points, which you can see in this example, though, has exactly that number, 1, 2, 3, whereas this one did as well. So kind of two similar graphs. The main idea here is just making sure you can, understand the multiplicity as well as the zeros. All right, so that was in factored form, and factored form is very, very important and helpful for us, especially when we're looking at understanding like the behavior of the graph in regards to zeros and multiplicity. However, what we will find out for the rest of this chapter is not always are we going to have things in factored form. A lot of times we're going to have something in standard form. Now, we haven't talked about how to solve these algebraically. So right now we just really looked at graphs and how those graphs behaved. So in this one, we're just going to look at the end behavior as well as the possible number of zeros and extrema. So, the main thing that I kind of review, and see, look at how much space I gave myself for this. I don't need that much space. But if you kind of remember as far as end behavior, leading coefficient test. So when we had y equals, a times x to the n, okay? A was our leading coefficient, and n is our degree. Yeah, okay. So when our degree is even, oh, what am I doing? Wrote that down wrong. So we have our degree. When it's even, it's either even or odd. And then our leading coefficient is either going to be positive or negative, okay? And the main important thing, that really all you need to know is, doesn't matter whatever my function is even, and it's positive. It's just like a quadratic. It's going to rise to the left and rise to the right. This is what I have memorized. Rises to the left and rises to the left and rises to the right. And if my leading coefficient a is negative, then my graph is going to fall to the left and fall to the right. Whereas odd kind of reminds me of either the linear identity function or the cubic function. It's going to fall to the left and rise to the right. And if my a is negative, then it's reflected about the x-axis. It's going to rise to the left and fall to the right. Okay. Now there's a way that we write our end behavior, and for our chapter on functions, I was kind of a little lax as far as how we're going to write that. But now we're going to use a little bit more mathematical notation, okay? So the main important thing when identifying the end behavior, which we'll just work on first here, is understanding, looking at the degree as well as the leading coefficient. And we also want to make sure we have everything in standard form, which I was nice to my students here. Everything is in standard form. Just remember, standard form has the degree, the highest power listed as the degree first, and then it's going down in descending order. So in this example here, I have an odd degree and a leading coefficient that's positive. So you can see this graph is going to rise to the right and fall to the left. Now, how can we write rise to the right a little bit more mathematically? So I can say rise to the right. That's G and H. Okay, now that's perfectly fine, rise to the right. Now the way that we talk about this is there's two things that are going. We're talking about it rising, all right? So if we're looking at a coordinate system here with this being f of x and this is being x, we're not using limit notation. For those of you that are wondering about limits, we're going to be talking about limits at the end of the year. So I'm not going to introduce my students to limits right now. We're just going to talk about how can we write these a little bit more mathematically. So if I want to talk about something rising, and we're talking about a function here, so we have like the f of x function, or in this case, I guess I used y, but either way, we can say that f of x rising basically means that the y values or the f of x values are approaching infinity, right? As my f of x values are going up, that means they're approaching infinity. And how can we write to the right? Well, that's my x values, and my x values are going to the right, they're approaching infinity. So we can say x approaches infinity. And then we also know that this graph rises to the right, but it falls left. So if rising is f of x approaching infinity, then falling would be f of x approaching negative infinity. And if going to the right is x approaching infinity, then going to the left would be x approaching negative infinity. Okay, and there you go. This next one, you can see that my highest degree here is 4, so therefore it is even, and you can see that my leading coefficient is negative. So again, this is just like a quadratic, but now it's being reflected about the x-axis. So the graph is going to fall left and falls right. Okay, so falling left would be f of x approaches negative infinity as x approaches negative infinity, and falling right would be f of x approaches negative infinity, and you could say as, usually as is a word that we add into there, as x approaches infinity. So the graph is going to the right, but it's falling. Let's work on the next one. We'll go ahead and use some green. This one, again, we're dealing with the odd degree, but now it's negative. So now you can see that this graph is going to rise left, but falls right. Okay, so again, if it's rising, that means f of x approaches infinity, and as it's going to the left, so then as x is approaching negative infinity, and then falling right, so it's falling, so f of x is approaching negative infinity, and as we're going to the right, so that means x is approaching infinity. All right. And then last but not least, let's go ahead and use some blue. You can see here, again, we're dealing with an even, but now we have our leading coefficient that is positive. So now it's just like a quadratic. So again, it doesn't matter if it's x to the 6th, x squared, x to the 16th. Anytime you have a degree that's even and the leading coefficient is positive, it's going to have the same end behavior, which this one is rise left and then rise right. Okay, so therefore rising left is going to be rising is f of x is approaching infinity, and going to the left would be x approaching negative infinity. Rising right would be f of x approaching infinity, rising right, as x approaches positive infinity. Okay, so all right, now what we're going to do is we're going to get on to some multiple choice questions. If you want to go ahead and maybe work on some of these, as I just go ahead and check in the chat from you guys. There we go, is the questions. I'll go ahead and go over these answers here in just a second, but I just wanted to say hello to a couple of you guys that have joined on. Atham, hey, how are you doing? Sorry if I mispronounced your name. Ken, good to see you. Garrett, Muhammad, Supreme Max, LGM Productions, Mazak, Leah, good. Glad to have you guys on here. I am happy to kind of be at it. It's going to be a busy week. I wanted to do some of these live streams last week, but my schedule just did not advise for it. And I told my students I would work on these live streams because we have a quiz at the end of this week and then almost, I think, a test on the week after that from Polynomials. So we're going to be moving pretty quickly. And I know some of you guys are, these videos can be good for college algebra, algebra 2, pre-calculus. For those of you that are working on trig, we are going to be starting that next. So pretty excited about that. And, that is about it. So just kind of see if you guys have any questions or anything else for this. I meant to ask, what grade is this for? Well, I teach pre-calculus this year, and that's the only class I'm teaching. Hey, Atham, super chat. Thanks, man. Thanks so much, man. You are actually my first super chat I've always had on this. So I really do appreciate that, guys. Obviously I'm here to, answer any questions you guys have, help you guys out. Probably be here for another 5 minutes. So if you guys do have any questions with them, feel free to, always put them in the chat and I'll be helping you out. And I am getting a orange screen, on my live stream. So I'm not sure if how everything is coming in, but I really do appreciate that. Again, the super chat, it's something that, is helpful. Obviously, as I'm trying to, build out a lot of this curriculum, which kind of goes into, if you guys want to, any more of the work that I am doing here, I did notice that I didn't get a recommendation here, or I'm not sure why this came up, but I wanted to welcome Taylor and Kelly for joining me on the membership on YouTube. As far as, one of those things, if you guys have seen it, like as far as the YouTube memberships, basically that what I have mine set up for is for those students that really want to kind of get access to this work and my answers. If you're not able to get on every live stream, and not everything that I make videos on, I only really do the videos for the quizzes as well as for the homework. But if you want to see the test, you want to see the test answers, you want to see my guided notes answers, doing the YouTube membership, or, looking at my Patreon availability, which is in the description, see if it's right for you. If it's not, totally cool. I'm going to continue making videos and continue being on these live streams, helping you guys out. So, but if that is something you guys, are interested in, always feel free to always, ask any questions from me, see if there's anything else I can do to help you out with that. So, all right. Well, let's go ahead and finish the rest of this. Sorry, I took away that. For these things. So hopefully some of you guys that were kind of in on a chat, maybe you might have kind of started some of these. And man, you know what? I did this homework like too quickly. I kept on following X to the 4. I should have done an odd degree, but either way, that's all right. Oh, actually, I did the odd degree on the next one. But let's go ahead and describe the end behavior of the functions. You can see here it's not in mathematical notation. So we have something to the even power. Okay, so something's going to be to the even power. So automatically, I know even power is either rise left, rise right, or fall left, fall right. I see that the leading coefficient is positive, so I know it's going to be rising left, rising right. So now I just need to find where that is, rise left, rise right. C. The next one says, find the x-intercepts of the polynomial function and state whether the graph crosses the x-axis or touches the x-axis. All right, so this one kind of gets a little tricky here because you can see there, you can see the powers with the x. Now, remember, guys, that when I looked into my formula, this was x minus c raised to the m. Notice that the power of x was 1. So when we're dealing with multiplicity, that's only time we're dealing with the only time we're talking about multiplicity is when we're looking at a linear factor. That means x is raised to the first power. This is not linear. So what we're going to need to do is continually factor that down so they are in linear factors. So I can do that. Now, you don't need to worry so much about this x squared. You could do it. You could write the x's like this if you wanted to. But you see that it's repeated, right? It's x is 0 and x is 0. So it's a repeated 0. Another way you could just write it, if you'd like to kind of have that multiplicity, would be like this, x minus 0 squared. Okay, x minus 0 squared is the same thing as x squared. But again, you can see where there's multiplicity there. And then we have x plus 5. And then we can factor this down, just factoring this, x squared minus 1 can be factored using difference of two squares, x minus 1 times x plus 1. So therefore we have x minus 1 times x plus 1. Okay? And so therefore you can see that all of these have a odd multiplicity. So the only one that has an even multiplicity is x equals 0. That means the graph is going to touch at the x-axis and turns around. So that one's good. So it could be that one, could be this one. It's not B. Okay, or it could be D. Now we look at 5, 1, and 1. These are all going to be crossing. So at negative 5 it crosses, and positive 1, negative it crosses. Oh, well, this one, obviously the wrong answer. So they're saying 1 is going to bounce. It does not bounce at 1. It has an odd multiplicity. Touches. Nope, doesn't work with that one. You can see here it's all crosses. So this one answer is A. In the equation, x cubed plus x squared plus 4x plus 4 equals 0, how many possible zeros does the graph have? Again, guys, we haven't, in this course, so far we haven't talked much about the zeros or the fundamental theorem of algebra. So that's a little bit ahead of my students. For right now, we just kind of looked at the degree of the polynomial and looked at the possible number of maximum number of zeros. And what we kind of identified was that the maximum number is going to be the degree of the polynomial. So that answer is going to be 3. And then the last one is my intermediate value theorem. Okay, polynomial or talk. And what we talked about this, the main important thing that with this problem is understanding that we are dealing with a continuous function. And really the investigation of polynomials, this chapter, is always going to be continuous functions. We're not going to be dealing with any discontinuities of some sort. So f of x has as value, as values as possible. And so what we need to do is understand where the zeros are guaranteed, because the intermediate value theorem, is I'm thinking my word, it's an existence theorem. It's basically saying that the zero is going to exist, but it doesn't tell us exactly where. So the best thing I would do for this would just be to sketch the points that we have, right? This is your x value, and there's your y value. So I'm just going to do a rough sketch here. So let's say -5, -14. And then we have -2, -1. We have f of 0, -8. Let's give these values. Let's call this A, B, C, D, and E. Therefore, we can kind of keep track of them. All right, D is going to be 3, 9, and E is going to be 6, 2. Okay. So what it's trying to tell us is if this is a continuous graph, right? There's no discontinuity. So therefore, I'm going to connect these graphs, we'll connect all these points. Between which values does there have to be a 0? Now remember, there has to be a 0 is when the y value is equal to 0. Like this graph, to go from C to D, there has to exist a 0 here. There has to be, because there's no way to go from C to D without crossing the x-axis. So that's what the intermediate value theorem basically is telling us. So now we just need to look at the interval from C to D. So again, that's really going to be the x values, which is going to be x0 to D. So therefore, you can see that answer is going to be C. And then I'm just going to wrap it up because I am kind of close here. But if you want to go and play around with looking at these zeros here, I just did a little algebraic stuff. Nothing kind of crazy I could think of for this one because we just kind of did a kind of introduction lesson. But again, just to remind you guys, if next live stream, I will plan on doing, I think, 2 of them tomorrow to prepare for the upcoming quiz, and then obviously at the end of the week I'll do a quiz over what I covered for you guys. So if you guys have any questions or anything else, feel free to always add questions into the chat. I always try to answer them as quick as I can, but obviously sometimes class and everything else gets ahead of me. If you guys have any last minute kind of quick questions, I might be able to answer some questions here real quick for you. So again, Athem, for your super chat, if you have any questions, man, let me know. Be more than happy to help you out. Otherwise, you're always free to join in. Next time. I do also really appreciate that. Crazy Alaska says, I love your vids. Thanks so much, man. You are very welcome. Yo-Yo Chris, happy to help you out. And the Kitty Gamer, you finally made it. Well, you finally made it. I am just about to finish, wrap up here. But again, guys, if you have any questions or want me to look into anything else, again, I will be going live next class period, or tomorrow around the same time. I'm thinking I'll probably do a 3 o'clock, a little bit earlier this time. So I'll probably do a 3 o'clock and a 3:45. So if you want to, catch me on one of those streams or right in between there, actually I'll probably do 2:45 to 3:45 around that time frame. Sorry. Right now, it's just kind of difficult, really kind of getting me to nail down when exactly I'll be available. But either way, guys, I think that is going to wrap it up for now. And then I will look forward to seeing you guys on the next live stream. And my computer, I should not do this next time. It's all messed up. I put my computer on my left side instead of my right side, and I forgot to change the mirroring. So crazy enough. All right. See you.